Look outside right now. The sun is shining. Now imagine it just switches off. Instantly. No warning. No countdown. No goodbye. You wouldn't even notice, not right away. For 8 more minutes, you'd keep smiling in sunlight. Then the sky itself would start to die. Within a year, oceans would freeze solid. So how would you actually survive this? Quick favor before we dive in. Hit like, subscribe, and drop a comment. It really helps. Here's exactly what would unfold, minute by minute. First, a delay you never expected. Then darkness, falling temperatures, and a broken orbit. Some life would find a way to survive. And by the end, you'll see the sun differently. Here's the strange part scientists always mention first. Sunlight takes about 8 minutes to reach Earth. It travels at the speed of light, 300,000 kilometers every second. So the sun you see right now already left 8 minutes ago. If it vanished this instant, you'd see nothing change. Physicists call this the light travel time delay. For 8 full minutes, Earth would look completely normal. Birds would sing, traffic would move, coffee would brew. Then, all at once, the light would simply stop arriving. Minute 8. The last photons finally arrive, then nothing. The sky wouldn't fade like sunset. It would just end. No twilight. No warning glow. Just sudden, total black. Streetlights would flicker on across every city at once. People would freeze mid-step, phones raised toward a starless sky. Wait, starless? Shouldn't the stars still shine? Yes, distant stars would still burn on, tiny and cold. But the one star that mattered most had gone quiet. Now look up for your old friend, the moon. The moon has no light of its own. It only shines because it reflects the sun. No sun means no moonlight, ever again. The night sky would lose its second brightest object. Only faint starlight would remain to see by. Imagine a night that never, ever gets bright again. Across the planet, phones would light up with alerts. In Tokyo, commuters would stare up from crowded platforms. In New York, a family would huddle by their window. In a small farm town, dogs would start howling. In London, a bus full of passengers would go completely silent. Confusion would turn to fear within minutes. Is this a blackout? An eclipse? Something worse? Social media would flood with the same shaky question. Why is the sun not coming up? Nobody watching the sky would have an answer yet. Inside a television studio, a news anchor would go live. Behind her, a red banner would flash, breaking news. In a government situation room, officials would circle a glowing map. Satellites would confirm what no one wanted to believe. The sun's disk had simply stopped appearing on every sensor. Astronomers at observatories would double-check their instruments in panic. This wasn't a malfunction. Every telescope agreed. The president's phone would ring before dawn broke, except dawn wasn't coming. The sun, impossibly, was gone. And that raised an even bigger problem than darkness. You've probably never thought about what keeps Earth in place. It's not magic. It's gravity, a constant invisible pull. Physicist Isaac Newton described it over 300 years ago. The sun's mass tugs on Earth, bending its path into a curve. That curve, repeated forever, is what we call an orbit. Take away the sun's mass, and that pull vanishes instantly. Gravity, unlike light, isn't delayed the same for giving way here. Once the sun's mass was gone, Earth's leash simply snapped. So what happens to a planet with no leash at all? Earth had been curving around the sun for 4.5 billion years. The instant that pull disappeared, the curve would straighten out. Earth would fly off in a straight line, forever. Not toward anything, just outward, into the dark. No explosion, no drama, just a quiet, endless drift. You wouldn't feel a thing, no jolt, no shaking. Gravity holding you to the ground would stay exactly the same. But the destination for everyone on Earth had just changed completely. Earth would keep spinning, just like always. So you'd still get a 24-hour cycle, technically. But day would now just mean slightly less dark. No sunrise, no sunset, no warmth to mark the hours. Clocks would matter more than ever and mean less than ever. And the temperature? That's where things would get serious. Within hours, thermometers would start sliding downward. The ground and oceans still held stored heat, for now. That stored warmth would leak into space, slowly, steadily. By the first night, temperatures could drop several degrees. Frost would appear in places that hadn't seen it in years. Farmers would rush to cover crops under emergency lights. News tickers would scroll temperature drops like stock market crashes. Meteorologists would issue warnings nobody had ever written before. And this was only day one. Every green plant on Earth runs on sunlight. It's called photosynthesis, turning light into food and oxygen. Without light, that entire process would simply stop. Leaves would stay green for a few days, running on reserves. Then, one by one, they'd begin to wilt and brown. Crops in every field would start dying within a week. Algae in the ocean would stop producing oxygen too. Forests, meadows, gardens, all fading at once, worldwide. And plants weren't the only ones about to go hungry. Nearly every food chain on Earth starts with a plant. Grasshoppers eat leaves. Birds eat grasshoppers. Foxes eat birds. Break the first link, and the whole chain shakes. Grazing animals would run out of food within weeks. Predators would follow soon after, hunting a shrinking world. Even bees, with no flowers blooming, would have nothing left to pollinate. Grocery store shelves would empty faster than trucks could refill them. Humanity's supply chains were never built for an endless winter. And the cold hadn't even reached its worst yet. By the 1-week mark, the freeze would be undeniable. Average temperatures could fall below freezing almost everywhere. Rivers in cold climates would start icing over at the edges. Snow would fall in places that had never seen it. A world map on a control room screen would turn blue. Scientists tracking the drop would compare notes in disbelief. The math, grim as it was, kept checking out. So how cold would it eventually get? Rain depends on the sun more than you'd think. Heat evaporates water, lifting it into clouds. That's the water cycle. Without solar heat, oceans would stop evaporating properly. Clouds would grow thin, then disappear almost entirely. Skies would turn a strange, clear, starving gray-black. Rain would become rare, then stop in most regions. A silent, dry, freezing world was taking shape. Governments wouldn't just watch this happen quietly. Emergency broadcasts would urge families to shelter and conserve heat. Cities would open community centers stocked with blankets and food. Engineers would rush to bring backup generators online everywhere. Hospitals would switch to reserve power within the first days. Families would gather around candles and battery-powered lanterns. Volunteers would go door to door, checking on elderly neighbors in the cold. A child might ask a parent, "Is the sun coming back?" And every day of silence would make the cold worse. 1 month in, and the numbers would be brutal. Some models suggest surface temperatures near minus 20 degrees Celsius. Within a year or two, far colder than that. Wind would carry ice crystals through empty, dead streets. Buildings would creak under snow that never stopped falling. Most surviving humans would already be underground by now. The surface world above them would look alien and still. But underwater, something surprising was happening. Oceans hold enormous heat, far more than land does. They would resist freezing longer than anything else on Earth. Still, the surface would eventually form a thick lid of ice. That ice sheet could grow meters thick within a few years. Coastal cities would watch harbor water stiffen into gray-white sheets. But ice is also a strange kind of blanket. It would insulate the water beneath it from the deadly cold. Deep down, liquid water could persist for a very long time. And where there's liquid water, there might still be life. In 1992, scientists Ken Caldera and James Casting modeled exactly this scenario. They asked, how long could life survive a sunless Earth? Their answer, surprisingly, wasn't never. Deep-sea biologist Cindy Vandover has spent years studying hydrothermal vents. These are cracks on the ocean floor spewing mineral-rich heat. Vent ecosystems don't need sunlight. They run on chemosynthesis instead. That means turning chemicals, not light, directly into energy. Giant tube worms and strange crabs already live this way today. For them, losing the sun might barely register at all. Life, it turns out, is far more stubborn than we assume. So could people actually survive this, long-term? Nuclear submarines already run for months without surfacing. They recycle air and water and carry their own power source. Underground bunkers with geothermal heat could, in theory, sustain small groups. Greenhouses lit by electric grow lights could keep some crops alive. It would take enormous energy, planning, and cooperation to pull off. Space agencies might even reconsider their orbital station designs for isolation lessons. Not everyone would make it. That's the hard truth. But a determined, resourceful few just might. 1 year later, Earth would be a dim, drifting ice ball. No longer curving gently around a warm star. Just tumbling silently through the emptiness of space. Its oceans locked under ice, its surface buried in snow. Somewhere below, pockets of warmth and life would still hum quietly. A strange kind of survival, in a strange kind of dark. It's a bleak picture, but also an oddly beautiful one. So could this actually happen to us? Here's the reassuring part astronomers want you to know. The sun can't just switch off. That's not how stars work. It's a slow-burning ball of plasma, fusing hydrogen for billions of years. Even its eventual death, in about 5 billion years, will be gradual. It'll swell into a red giant long before it fades. This whole scenario is a thought experiment, not a warning. Astrophysicists use experiments exactly like this to understand what stars really do for us. And that understanding changes how you'll see the sky. So look outside again. The sun is still shining. That warmth on your skin left the sun 8 minutes ago. It's been traveling, quietly, this entire time, just for you. It grows your food, drives your weather, lights your days. Every sunrise you've ever ignored was doing all of that. It's easy to take a star for granted. Until you imagine, just for a moment, that it's gone. So, go outside and actually look at your sun today.